To construct the histogram, we first load the required packages. Import NumPy as np, import matplotlib, .pyplot as plt, separate the variable you want to graph by the overlay you want to see. Since we are creating a histogram of age using an overlay of response, we separate the variable age, bank underscore train age, by the two values of the variable response. Save each piece as its own variable. You may refer to this command. The result is two variables, bt underscore age underscore y and bt underscore age underscore n, which have age values for only those records which have response equals yes and response equals no, respectively. Once the variable is created, create a stacked histogram of the two variables using this command. For the hist command, the input stack equals true will stack the two variables while bins equals 10 specifies the number of bins in the histogram. The legend, title, X label, and Y label commands specify the values of the legend, title, X axis label, and Y axis label. Finally, the show command will display the figure. Using this command, we will now create a normalized histogram. First, create a stacked histogram, but this time, save the information generated by the histogram using this command. The left-hand side of the code saves several pieces of information from the histogram. Specifically, n is the height of the histogram bars and bins are the boundaries of each bin in the histogram. Note that since two variables are being plotted in the histogram, n has two series of numbers. The first series is for the first variable and the second one is for the second variable. The first number in each series is the height of the first bar for each variable. To create our normalized histogram, we need to know what proportion of each bin each variable represents. To accomplish this, we need to put the information contained in N into a matrix and obtain the column proportions. To begin the construction of the matrix, combine the heights of the two variables bars into one array using the column underscore stack command. Using this command, the result n underscore table is a two-column matrix where each column's entries hold the heights of each bar. To calculate what proportion of the bar is accounted for by each variable, we need to divide each row by the sum across that row. We use this command. San? San yung command na yun? Here. Now, each row in n underscore norm sums to 1 and the columns within each row give the proportion of that variable that makes up the row. In our final preparatory step, we create an array whose rows are the exact cuts of each bin. Through this command, each row in our bins gives the upper and lower bounds for each bin. Now we are ready to create our normalized histogram using this command. In the bar commands, the X input specifies the upper and lower bounds of the bins. The height input uses the normalized count values we created previously to specify the height of each of the two sections of each bar. And the width input reuses the bar widths from the original bar chart. Based on this command, it specifies the second of the two bar sections of the start on top of the first. The remaining commands are the same customization options we used in the stack bar chart previously.